morning. I hope you were not as stuck as me in the traffic. It was pretty bad. But thank you so much, AIM, to invite me here, and it's a wonderful, gathering, as I must say, and a wonderful introduction, by the way. I hope AI hasn't generated it, but we live in that era. Initially, I thought I've been called for some Air India conference where I'll get a gold membership because a space guy coming into an AI conference is very odd, right? But when the organizers invited me, I thought there is some substance behind it. So, well, let's switch some gears and go to space for the next 15 minutes. Now, space, of course, is a different subject, is a subject where we always thought about ecology, environment, agriculture. Now, in the recent geopolitical events, we're thinking about defense and security, and so on and so forth. So let me kind of give you a little bit of 101 of where we are as a country, where we are as the space tech community today. Suyash, founder and CEO, GalaxEye. I'm very happy to be here introducing space tech. This particular picture, if you just focus on for a moment, this is what we do on a day-to-day basis. You get up probably in the morning, open your phone, you either are ordering something on Zepto to get some food, or you are going to your office, you're going to use a car, or rather a ride-hailing app, be it Ola, or Uber, Rapido, and so on and so forth. Now imagine a world where GPS, which is powering all of these apps, doesn't work when it is cloudy, right? Rain or shine, GPS works, fortunately, but imagine a world when it doesn't work when it is cloudy. And when it is non-cloudy, it works. Fortunately, that doesn't happen in GPS, and we have all these 10-minute delivery things happening. We're a great country with all the 10-minute to 5-minute deliveries and whatnot. But unfortunately, this happens in other world, which is the satellite imaging world. Now, space tech, for all its hype, has only 3 applications. You build a rocket, you build a satellite, you build anything whatsoever, is only for three applications: communications, navigation, and Earth observation. Communication, we use it on a day-to-day basis, and one of my earlier speakers said Elon Baba doing a lot of things in that space. Sure, communication has been nailed by some of the companies across the world. You will have access from space, from ground, everywhere. Navigation, like I said, rain or shine, it always works. Just one thing doesn't work from space today at scale is imaging. And hence, we as consumers don't use it on a day-to-day basis. Now, why so? Because space imaging or cameras can't see through clouds. And Earth has a very different variable cloud cover everywhere. In the tropical regions, you have larger cloud cover. In the non-tropical regions, you have lesser cloud cover. Satellite imagery is very intermittent, inconsistent because of the cloud cover, which is variable across the world. Now imagine you're building an application for agriculture. 2 months, there is monsoons, you have no imagery whatsoever. Hence, you've not seen companies building SaaS applications on top of satellite imagery. There's hardly a unicorn in the world, not in India, not just in India, in the world, who has been able to use satellite imagery and build an application that. But you must have seen unicorns which are built on navigation and communication. Now, to solve this problem, a couple of options are available, and just to kind of, run it down. First option is take a camera, put it on a satellite, launch it through a SpaceX launch vehicle or a PSLV from India. You go to space, it's in the orbit, you start capturing images. That is optical. But whenever it is cloudy, you can't see through it. People also ventured into something else, because of this cloud problem, which is nothing but a synthetic aperture radar, or SAR. Now, don't worry about it. There's not a radar lecture. SAR is very similar to how an X-ray image looks like. It can see through clouds. It can do nighttime imaging. But it's like X-ray. Only doctors can read it. You can't really understand it. So on one hand, you have an imagery like camera where this audience can do AI is not available. And then you have radar, or synthetic aperture radar, which is always available, where you will have to go through an extensive training to understand what it is. This world is struggling between these two to create more and more unicorns moving forward. And hence, inconsistent SLAs, or service level agreements, with the customers. This is what we are changing at GalaxEye. We are building not just India's first, it's world's first multi-sensor satellite, combining SAR, synthetic aperture radar, and electro-optical, or rather camera, together on the same satellite to give out a data set which is called Singh-fused OptoSAR. Now, what does that mean? That means when you have clouds, you can't look at this multispectral image if it is fully cloudy. You'll only see a part of it. But with SAR image, you can see that image. But let's say if I haven't given you the right or the left, was it a pair of shoes or was it a pair of ships? You just can't understand it. What we are building is getting this image at the end of the day. By the way, we haven't launched the satellite yet. This is one of the simulated images to show you the difference. But interestingly, just imagine today, over KTPO, there's no clouds. I'll have both the images, optical and SAR. Tomorrow, over KTPO, there is clouds. I will only have SAR, I will not have optical. What does one do on day 2? That is the reason why I'm here. We regenerate an optical from the SAR image. Like this. So we build satellites, and we build very interesting state-of-the-art foundation models in the satellite imagery world. We can't take a YOLO and then train it further along and then build a model on that, because the perspective is this. The satellite imagery perspective is from the top. So to use lesser annotated data, to use lesser data for all the training, by the way, I'm not very sure about all the terminologies like LVMs and LLMs, pardon me for that. But I'm collecting data on top of which a lot of AI models can be built. This data is super useful. Our journey so far has been very interesting, thankfully to a lovely team and the mentors that we have gotten. We started very humbly putting together a sensor stack on drones. Like Tanay said, we are a country where capital may not be as much available. So we can't build satellites, send it to space, and then reiterate. I can't run a for loop in space, right? But I can do jugaad. or rather innovation in India. We miniaturized the sensor stack that will go on satellites into a very small form factor. We put it on drones. We flew it like 200, 300 times, got the right imageries, validated it. Then we went to HAPS. Now, HAPS, again, is a new terminology, but the full form of HAPS is high-altitude pseudo-satellites. So it actually hovers at 18 kilometers height from where you can do the imaging. Now, if you put it on a HAPS, you're almost touching space, right? Because that's where the atmosphere ends. So we tested it on a HAPS, got a lot of good data, and hence our sensor stack was kind of qualified. From there, we did a PSLV launch last year, December 2024. It was a wonderful launch. We went up to an altitude of 450 kilometers. On the same launch, SpaceX mission also happened, where we did the first proof of concept of Bharatiya Antariksh Station, which is BAS. And finally, we're geared up to provide world with an unparalleled data with Mission Drishti, launching in Q1 2026. Thank you. Now, this is getting launched on a SpaceX launch vehicle from Vandenberg in California. Now, what do we do after generating these images using satellite and then AI? Now we go about building the Ubers of the enterprises. The market is a little smaller when you see $2 billion in numbers, but it is smaller for a reason, right? It has been a niche market for a while. There were not many satellites that were launched until, say, last 5 years. Hardly, say, 10, 15 Earth observation satellites used to exist in 2015. Today, it's around 500 satellites, and we live in a world very shortly where we'll have 5,000 plus satellites imaging the Earth. Hence, a lot of use cases will get unlocked, and the use cases, I can just say some verticals, for example, defense and surveillance, maritime, agriculture, insurance, disaster management, aquaculture. But you just name it, any large real estate on Earth where you want to monitor it consistently. Say you want to monitor your farmhouse every 7 days throughout the year. We'll actually, a lot of satellite imagery companies, by the way, gives you a platform where you can go and draw an area of interest and task the satellite imagery, get that data, perform your analysis or AI. Our journey doesn't stop here. Our journey goes beyond that. We want to become the best satellite imagery data provider in the world. Our journey starts with Feb 26, launching one satellite, going all the way up to launching a constellation by 2030, 10 plus satellite constellation, and that's where we'll have a 3-hourly revisit of any point on Earth to be given to you. This is the best time to build a space company in India, be it on the downstream or on the upstream. Like Tanya was mentioning about the Chandrayaan moment, truly so. I was traveling to the US, meeting somebody in the strategic world, and he mentioned, India launched a Chandrayaan mission literally for a cost of a department in the US. So they will set up a department for, say, $7,500 million, for which we have really launched a Chandrayaan-3 mission. So we have the capability. We have the supply chain. In India, we're building the world's first technology to gather the right data. So what next? Next up is to build analytics, right? And I say very fondly, And cheekily, that if you are going to put an IoT device on an agricultural field across the India, or if you're going to put cameras and CCTV across the India on the rail and the roads and so on and so forth, vandalism is inevitable, unfortunately. So if we need a digital infrastructure to monitor the larger landscape of India, we need these solutions. And we are here to provide you all the right kind of data sets. Like I said, there are many use cases, starting with agriculture, disaster management, defense and intelligence, and utilities. A prime example, which I must call out here, is the defense and intelligence piece. I'm sure a lot of the audience would have heard about a company called Palantir. Awesome. Palantir has a product. It's called Gotham. Check it out. It's a platform where US Department of Defense does all its intelligence. Although it's a data aggregation platform, it's kind of an AI platform that gives you all the data at one place to perform, a specific use case that a DoD user would want. The reason why I brought it out is we work in an industry, or rather, defense is an industry where the data cannot go out of the premises. The data will always be with them because it's the question of intelligence. Now, Palantir wonderfully trained its talent to work in an air-gapped environment where the data hasn't been shared here and there. The deployment strategist planned the deployment where they can't leak the data or they can't use data from outside. They have to use the data what was available to them. They took their solutions to their premises and innovated maybe on the edge or innovated around the strategies of training. So one good thing about this is a lot of people who have come out of Palantir have gone in building probably one of the best models in the industry, starting with Claude, Llama, and so on and so forth. So you should definitely consider, a Palantir-like model. And one of the data set that is available is from GalaxEye. I think I've repurposed my space slides for your AI thinking as much as possible. But thank you so much for having me here. And this was me. Happy to take any questions if anyone has.